friends, hello everyone, welcome back to Tanmay Tutorials. Your go-to place for a clear, simple and complete explanation of all the important graphs in mathematics. It is useful in physics as well as chemistry also. Whether it's a linear, constant, modulus, exponential or even trigonometry. My aim is to cover the every concept of the graphs in this video. So let us begin the video without any waste of time. First, let us go towards a simple graph, that is a linear graph. The characteristics of the graph is the graph forms a straight line which passes through the origin. So next, usually it is represented in the form of equation of a two variables, that is y is equal to mx plus c, where y and x are the variables, where m is called as slope of the graph and c is a constant. And if first degree of equation, that is highest power of the variable is 1, and in this linear graph whatever the variables is there, its highest degree, which is nothing but its power, will be always equal to 1. And next is graph represents the uniform rate of change of quantities, that is its slope is nothing but a dy by dx, nothing but the rate of change of quantity on the y axis with respect to rate of change of quantity in the x axis will be always increasing in a uniform rate with a constant rate. Okay, no varies. Okay, it doesn't varies, it will be increasing or decreasing in a constant rate. That is why we will call it as. So if the line is passing through the origin, then the c, constant c will be equal to 0. If the c is equal to some any number which is not, if c is not equal to 0, then the graph will comes like this, which will be not passing through the origin. Okay, let's go for the next graph. Same graph, but it is in the opposite sign, where y is equal to minus mx plus c. Here c is equal to 0 because the line is passing through the origin. Characteristics of the graph is same as I told for the before graph. All the characteristics are same, but the sign remains opposite because x-axis values all lies in the second and third quadrant. It's lying in the second and third quadrant. So since x value in second and third quadrant is negative, hence the graph value will come y is equal to as negative values. So next thing is, now let us go for our third graph, that is the constant graph. The characteristics of constant graph is the equation of a constant graph is in the form of y is equal to c. So the graph will be represented as y is equal to c. The graph is horizontal line because the value remains same for every x value. Can you see where I have inputted many x values? See, whatever input is there, it is all the x axis. Okay, it's all the values of x axis. Whatever the output is there, it is a value of y axis. Okay, whatever I given the x axis value, okay, see x axis value whatever I have given, you can see whatever the x axis value I have given, all for all the x axis value only one y axis output is we are getting out. So that is why it is a constant, why we will call it as a constant. And the slope, that is the rate of change of some quantities, will be always 0. That is, always remember the slope for the constant function will be equal to 0. Therefore it is a neither increasing function nor decreasing function. And since the line do not rise or fall, it is always parallel to the x-axis. Okay, this is always parallel to x-axis. If it is a constant, if a x value is constant, then simply the graph will come like this. That's it. Okay, at the time your x value will be lying constant for every y values, but here we are considering a x as a input and y as a output. I think hope you understand about the fourth graph, that is modulus graph. The characteristics of modulus graphs is the basic equation of the graph will be equal is y is equal to mod x. The graph is v-shaped with respect to the point of origin. Can you see the point of origin 0, 0, and the output of y is never negative because we are putting the modulus. So modulus makes always the positive of negative value of x also as a positive values, and always the output y will be positive for it. And the graph is a mirror symmetric on both the sides of the y-axis. So it can also, the graph can also be like this, my dear students. It can be also like this. At this time the equation of the graph will be like this. Equation of the graph will be like this: y is equal to minus mod x. Whenever, see, if I take the value, if I consider the x value is equal to minus 5, okay, if I consider the x value as minus 5, if I give x value as minus 5, okay, so let me consider like this. Okay, then y will be equal to, minus of, so mod of minus 5. Always remember, mod of minus 5, mod of any negative value will be equal to positive values. Therefore it will be equal to y is equal to minus, and mod of minus 5 is plus 5. So ultimately we will get it as minus 5. So therefore the graph will be like this in the negative, x-axis, that is negative, sorry, negative part of the y-axis. This is positive part of y-axis, then this is negative part of y-axis. Like that we will get the graph. Okay, now let us consider the fifth graph, that is the quadratic graph. Can you observe this? So this is a quadratic graph where its equation is simple. Equation is y is equal to x square. See, the graph is in the shape of parabola. See, quadratic graph is there, no, it will take the shape of parabola. Okay, but the quadratic equation standard form, equation form will be y is equal to ax square plus bx plus c, and the graph will be symmetrical about its vertical line. Can you observe this? Y is equal to, that is x square, that is in the positive direction of y-axis. If it is in the case of y is equal to, if it's in the case of y is equal to minus x square, then the graph will be showing like this. Okay, it will be showing in the negative part of the y-axis. And also remember, I will say about the four different parabolas, that is, which is written by this equation. That is, let me consider the four different types of parabolas here. So yes, we have like this type, and this one, and this one. See, this is all a quadratic graphs only, but they are taking in the shape of parabolas. And let me give you the parabolic equations here. See, the parabolic equation for this particular graph will be equal to x square is equal to 4ay. So this is your and for this particular graph, x square is equal to minus 4ay will be the equation of this graph. And for this particular graph, the equation will be equal to y square is equal to 4ax. Okay, so next for this particular graph, okay, this graph is not looking nice. Wait. Yes, for this particular graph, your y square will be equal to minus 4ax. This is because it is in the negative axis, negative x-axis. Can you observe, this is a negative x-axis, right? So that's why. So I think hope you understand about the four different parabolic equation. So these are the four different parabolic equations, okay, of the quadratic graphs. Okay, now let us go to the sixth graph, that is exponential graph. So it is not a straight line. Can you observe this one? It's a curved line. It may be increasing or decreasing rapidly. And the graph is always passing through the point which is on the y-axis, that is 0, 1. 0, 1 represents the y-axis. And the graph will never touches the x-axis. Okay, and the domain of the function, remember, it's very important. The domain is nothing but an input, that is the value of x is always the real numbers, whereas the range is always the positive number, that is the number which is greater than 0. How? Let me explain. I said you the domain is nothing but the x values. We can give any real numbers, that is here. Can you observe, e to the power of x, I can give e to the power of minus 1, like that. Okay, see, for example, So I can give e to the power of minus 1, e to the power of minus 1, it will become y is equal to 1 by e, like that it will become. So I can give any values, I can give e square, I can give e cube, I can give any real numbers. Okay, but in the case of range is nothing but the output. Okay, if I give, for example, if I consider, my dear students, y is equal to e to the power of 2. Okay, e square something. Okay, what's the value of e? Something like 2.7, like that, right? 2.7 whole square is some positive numbers, right? It's a positive number which is greater than 0. That is why what they are saying, that the range is always a positive number which is greater than 0. Similarly, if I give the negative numbers, I can consider all the real numbers, right? If I give the example e to the power of y is equal to, let me give the x value as minus 2, what it will become? Y is equal to 1 by e square. It will go to the denominator, right? So then y is equal to 1 by 2.7 whole square. Whatever, if I do this one, okay, value, after solving this one, I'm gonna get the answer which is greater than 0. You can check that one. Okay, y is equal to 1 by 2.7 whole square, if you do, means you will get the number which is greater than 0, or the positive numbers only, no negative numbers. So I can say domain is a real numbers, whereas range is always positive numbers, it is greater than 0. Let us see the seventh graph, that is log graph. So in the log graph, same, it is not as a straight line, it's the curved line which is increasing or decreasing. Can you see this? The curved line graph which passes through the point 1 comma 0 on the x-axis, and the graph never touches the y-axis. And also remember, the domain of the function is always the positive real numbers, whereas the range of the function is always all the real numbers. How? I just explain you. See, the log x, whatever we will give the input to the log x is always a positive real numbers. There is no negative for log. Okay, log of minus 1, never. So always log value starts from log 0, log 1, log 2, like that. So always it's a positive real numbers. Whereas the range, it can come any real numbers. Okay, it can be negative, positive, 0, anything it could be. Okay, so that is about the logarithm function. Our eighth graph is cubic graph. You can see the characteristics of the graph. See, domain is all the real numbers. We can put all the real numbers as a domain, and ranges is also all the real numbers. So, and its intercept is at origin. It's something but it is touching at the graphs, that is x-axis and y-axis at the origin, and it is the odd function with with symmetry, that is, and it is a HS shaped curve. So odd function is nothing but, my dear students, remember, whenever you give f of minus x, your function will be equal to minus f of x. At that time, your function is said to be the odd function. Let us take an example. If I consider the x cube is a function, right? If I consider the 2 cube, it will be equal to 8. If I consider the minus 2 cube, then it will be equal to minus 8. So that is f of minus x is equal to minus f of x. Then it is called as odd function. So I think hope you understand about the cubic graph. For our ninth graph, that is the root function graph. See, the domain of the function is non-negative numbers. Here always remember, inside the root we cannot never give the negative numbers. It is a not defined number. Next, range of the function is also the non-negative numbers. If you are not giving input as a negative numbers, obviously output will be also not a negative numbers. A smooth curve that starts at the origin and will rises above slowly, and the graph is not symmetric about the x-axis, y-axis or origin. It is not symmetric about any point. So that was about the y is equal to root x. And I also say one thing about this y is equal to root x. Remember, see, we know this y is equal to x square, right? See, if it is if I consider the y is equal to x square, and I can write this y is equal to x square, okay, like this, root y is equal to x, right? Because x square, if it go away from the, like, opposite to the equals, it will become root, right? So see, what is the y is equal to x square graph? We know that y is equal to x square graph was like this, right? So similarly, y is equal to root x. If I consider y is equal to root x, I have shown here the root x graph is like this, right? That is, y is equal to root x graph is like this. Can you see this? So these two functions are a reflection of each other, like this. Let me take off part of it, like this. This is the x square graph, and this is the root x graph. So can you see this reflection of it? So this is a reflection graph. So can you see the reflection graph of it? So that is the reflection. Okay, this is what x square graph, this is what root x graph. Okay, that's it, that's the additional information. Now let us go for our last graph, that is 10th graph, that is y is equal to 1 by x. Okay, that is a real number function graph. See, the domain of the function is all the real numbers but except 0. We cannot put 0 because 1 by 0 is not defined. Similarly, range of the function is all the real numbers except 0 because 0 we are not at all getting, because input if it is not 0 then output is also not 0, right? Next, and no and xy intercept can be seen. Can you see the x and y intercept here? No, you cannot see. It's nothing but both the graph, whatever you are writing the graph, it will never touches the x or y axis. No intercepts can be seen. Okay, and next it is, and because here x is also not equal to 0, y is also not equal to 0. Whenever the graph is meeting, see, whenever the graph is meeting the graph means, so at that point any one of the points should be 0. So in this case it is a 1 comma 0, so y axis will be equal to 0, but in this case it will be equal to 0 comma 1 like this. So but it is not like that, because if x is also not equal to 0, y is also not equal to 0 means obviously we cannot find no intercept. So that is we cannot find the intercepts, that's the, but the graph will not touches the x or y axis. Okay, and next it is an odd function. Odd function means I have already said, that is f of minus x will be equal to minus x, that is so let me take an example of it. For example, see, that is f of minus x will be equal to minus f of x. If I consider the example, y is equal to 1 by x is our function. If I consider y is equal to 1 by minus 2, y is equal to what? It is minus 1 by 2, right? So the y value will be equal to minus 1 by 2. So as y value is minus 1 by 2, so therefore it is also negative. So therefore it is called as odd function. I think, hope you understand about this y is equal to 1 by x graph. So this was all about the graph, that is the all the graph which was present, which is always occurring in your science concepts or mathematics concepts. I think, hope you understand and like this video. So please like this video, please like at least for my efforts, and please subscribe the video and subscribe to my channel. And if you need any videos on this topics, please comment in the comment section. Thank you everyone, thank you for watching. Bye bye, have a great day.